Hello, everybody. Terry and I are here because we're going to speak to you about an automation framework we're developing over here at Snowflake Cloud Engineering called Avalanche. Terry?
Yeah, this is a chunk of software that we uh, went online to have a look, see if there's other things to do to solve the problems that we're having as we try to build our infrastructure here at Snowflake. And after a lot of research, we sort of reached the conclusion that there really isn't anything that does what we want to do. So we embarked on building this framework ourselves.
Yeah, so we're going to take you through a little bit of what it does, how it works, and sort of some of the assumptions we made about this framework that makes it different from the stuff that's out there today. A little bit of a legal disclaimer here. I'll just leave that on the screen for a second. But let's go through a little bit of an agenda of what we'll be talking about in this presentation. We're going to talk about what the tool is, why it's good, what we use it for, some of the features it has, and some of the goals we want to accomplish with this tool. So let's move right along to what is Avalanche? Well, it's an automation tool we wrote in Golang. If you're not familiar with Go, it's a really excellent programming language. I just learned it fairly recently, and I absolutely love it. It's being developed by Snowflake in the cloud engineering team here, and unlike other automation tools you may be familiar with, like Jenkins or Ansible, it's really designed to provide end-to-end automation, where it can take your workflow all the way from nothing right to the end. Whereas, tools like Jenkins kind of really only do like a small piece of the project. We have broad support for things like Teleport, SnowSQL, Kubernetes, Terraform, Pulumi, and we've tried to make it really easy to add more stuff into it. We've broken down the operations that Avalanche does into these little packages. We call them modules. And the modules are basically just collections of workflow steps and relating that and things that relate to each other.
Yeah, I think the only thing I'd add to that, Alex, is the comment that you made about end-to-end automation. There's like some of the tools that you mentioned, things like Ansible, Terraform. They solve a kind of a really niche kind of problem. They'll do like one particular task, and I
Yeah.
think something that a lot of them miss is that they have no consistency in the way that they consume data and the way that they produce data. So something like Terraform, it has its own domain-specific language where you describe how to build your infrastructure, and the outputs from it can be in a couple different forms, but it's not any standard way. So one of the main goals of Avalanche is to coerce the data that goes into and out of any external tool or directly calling some other tool into a standardized format so that we can make the flow of data from one operation to another very well defined.
Yeah, Terraform does a great job at standing up infrastructure, but once your infrastructure is up, what now? What if you actually need to do something on that infrastructure? Well, now you have to try to jam in some other thing, and there's no real easy way to get that Terraform data into the next thing.
And there's no way that Terraform knows, okay, I've stood up the infrastructure, now I need to launch Ansible, or I need to run a script on something, or there's nothing that coordinates it or determines the order of operations.
Exactly. So some advantages of Avalanche, we've already talked about a few of them, but one of the biggest ones is that it's defined by code. Everything Avalanche does is in this YAML-based syntax, and the YAML comes from a GitHub repo or any GitOps, follows a standard GitOps flow, so changes are peer-reviewed and branched, and there's commit history and all of that. It basically means that everything Avalanche does is prescribed by a predefined set of code. So there's no someone runs a script on their laptop and then has to remember exactly what parameters they have to put in to make it work. And then there's, we had a lot of that before where they would be like, oh, run this script with these parameters, and it wasn't always clear what the right parameters were. And maybe once they figured them out, they didn't then pass that information along. And so now everything that you want Avalanche to do, every part of your automation, whether it's running Terraform or Ansible or anything else externally, it's all pre-described in these code files. Any comments on that, Terry? Or?
No, I think you covered that one pretty good.
Right. So what good is code if you don't have an ability to make sure things are doing what they're supposed to be doing? So we've defined testing as a core functionality. It's basically a requirement for Avalanche to work properly. Everything that Avalanche does has to first sort of pass a test, and then before the work happens, and then it does the test again. So this little diagram on the screen here is a sort of a simplified representation of an Avalanche module, where a module defines the things it needs to do its work. Then it will check and see if those things actually need to be done, whatever the operation is. Then it does the work, and then it checks to see if the work was actually done successfully. So if you don't define a test for your operation, you will never actually progress in the automation, because there's no way for Avalanche to tell if the work finished. So, using Terraform as an example, let's say your Terraform stands up a new EC2 instance. Well, a test might be make sure that instance is actually online and responding. So if your Terraform failed in some way, well, your instance isn't going to be online, and therefore the test will not succeed and your module will not succeed. And by making this a core component of every module in Avalanche, you can be sure that as the automation flow progresses through, everything before it had succeeded.
Yeah, to sort of build on Alex's example there, the requires and the provides. So the requires may be something like the name of a pool of VMs or something like that, and then the provides from that module would maybe be the list of IPs of virtual machines that were stood up. Because then you may have a subsequent module that says I want to install an Nginx web server. Well, what does that module need? It needs to know the IPs to install them on. So the Nginx module just says, I need the list of IPs. And then Avalanche uses the requires and the provides in your module to say, oh, this Nginx module needs a bunch of IPs, which is provided by the Terraform module. So I need to run the Terraform module first to get those IPs, and then I can run the Nginx module to pass those IPs over.
And this brings us really smoothly into our next slide, which is that the dependencies are sort of a core functionality of Avalanche. What Terry just described is the way that the requires and the provides of each module enforce a dependency flow. So rather than in a traditional automation or step-based system, you might say do this, then do this, then do this. Instead, with the Avalanche flow, you say this thing needs A, and this other thing provides A, and then because there's a clear indication of what one thing provides and what another thing requires, the two things can be attached together automatically using the flow of information in Avalanche. So the neat thing about this is you get an automatic dependency tree where everything happens in the correct order without you ever having to tell it what order to do things in explicitly.
Yeah, it gives us a couple of extra, like Avalanche supports sort of like a compile time validation. So when you hand it a set of modules, you can say check that that it is actually possible to build a dependency tree. In other words, you didn't have a module that requires something that nothing's providing. So it can check that it can actually be built. This also gave us the other advantage, and you typically don't get into this until you have kind of larger organizations where you have different teams responsible for different parts of the infrastructure or different software components. So what this means is that now we can have different teams within Snowflake building the modules independent of each other. So team A may be the one standing up the Terraform, but team B may be the one building like Nginx servers, and team B doesn't know anything about Terraform, and team A doesn't know anything about Nginx. And so now they can effectively own these modules because they're in independent files. So that team can have full control over saying, oh, I just care about the IPs of these servers. I don't care whether you stand it up with Pulumi or Terraform, or you're calling the cloud vendor's API directly and standing them up that way. They don't really care. All they need is, how do I access these machines?
Exactly. And one of the nice things about this type of flow is that you can actually swap out a module later on. Let's say you decided you wanted to go from using Terraform to using Pulumi. You're going to switch it to a different module. You don't actually need to let any of the downstream modules know that change happened. It's just automatic. Additionally, this is exceptionally useful when you're working with different cloud providers. If you're working with both, for example, AWS and Azure, your Terraform on AWS is going to be very different from your Terraform on Azure. But in both cases, you're standing up a new, in AWS, it's an instance, and in Azure, it's a VM. But the end result is the same. You have a machine with an IP address, and now you can pass that IP to to the next module, which can now perform the next operation. And that next module doesn't actually care whether it was an Azure or an AWS instance. It just does its job. And then this brings us to the next thing, which is that Avalanche actually manages that data flow for you. So if your module needs a piece of information, whether it is just a piece of data like an IP or a route table or a availability zone name, or even something like a secret, that's part of what you declare when you define your module. You say, I need this piece of data, and Avalanche will go and get it for you from wherever it comes from. And as a part of that, we were able to build a really robust secrets engine into Avalanche. Previously, if you've ever written a shell script that needed a secret, like an AWS token or something, you've probably had to put it in an environment variable, or maybe pass it on the command line, or maybe hide it in some script somewhere, or maybe you have like a complicated set of shell scripts that goes and connects to Vault to pull it out. We've replaced all of that. Avalanche is you just tell it you need this secret, and Avalanche will go and get it for you in a secure way. It will keep it in memory only and make it available to your script or to your module in whatever mechanism you need. And because that flow is controlled, Avalanche will make sure that secret actually exists. And that let's say you're getting a fresh token for something, the token will actually be valid and not expired. And so this already cuts off a lot of problems that we've had in the past with automation flows that were working using where every script had to define its own way of getting secrets. We also understand that data changes, and Avalanche keeps track of changes in data and will actually understand, hey, this module was run with a piece of information, but that information has now changed. Let's say we stood up a server and the server crashed. We had to make a new server. The IP address has changed. Avalanche will understand that and will now tell you, hey, this IP changed. We need to do the setup step again because the new server probably isn't set up. Any comments on that, Terry?
No, I think you nailed that one.
All right. So if you've ever used something like Ansible, you know that it's all just command line based, and that goes so far. But sometimes just being able to have a glance at something, this is the modern world. We have the user interface. So Avalanche has a very powerful interactive user interface that, among other things, allows you to, at a glance, just look and see what the status of your automation flow is with nice colored boxes that turn green. This is particularly useful for people who maybe aren't the engineers that are actually using the automation flow. We've been able to give this tool to our managers, and they go and look at it, and they say, aha, I can see how far along everything is by how many green boxes there are. And you can click on each one and see what's going on with it, what's wrong with it, look at what it last did. It's really awesome to be able to just at a glance see what's going on with the automation flow.
Yeah, and I think the other thing worth mentioning at this point is the way that this is actually implemented is the backend engine that Avalanche runs is an Open API 2 compliant interface, and the front end is just written in React. So the components effectively cooperate with each other. There's not any magical special thing that the front end does that you couldn't do by just talking to Avalanche's Open API interface directly.
Yeah, exactly. And the UI also gives us the opportunity to allow people to enter data into it, where previously a shell script might have required some complicated set of parameters that you have to type on the command line, or maybe some Ansible inventory files that you have to create. Now we can get that information by different teams. We can be like, hey, go log into the UI, type in the information we need from you, and then that will be captured, and now we can start the automation flow. In an ideal world, automation would have no user like input needed, but it's going to be a while before we get there for absolutely everything. There's always going to be some external dependency on Bob in engineering who needs to go and type in his his information.
Yeah, I think sort of going back to the flow of information change, what that means is that we can sort of start out developing it where you have to enter a bunch of data in through the UI, and then later on, maybe we have a different source that comes from. We have a central information repository, which the Avalanche will make a request to the API to retrieve the information, and so then we can swap out the module that provides that from a UI entry to a go get it from this external source, and everything consuming that doesn't have to change.
Exactly. So what are we actually using Avalanche for within Snowflake? Well, so our biggest project within Snowflake is deployment automation. This was the project we actually developed Avalanche for. Snowflake has deployments, which is our internal name for every sort of place that Snowflake exists in the world. And previously, to bring up a new one of these, it would take a team several weeks to do this. And with Avalanche, we've been able to bring this process down to just a few days, and we're still not finished. We're actually going to try to bring it down to even less than that, probably less than a few hours. And the reason that we ended up needing to develop this tool is that the process previously was someone would run Terraform, and then someone else would run some Ansible, and then you would contact a different team of people, and they would go and set up something in an FTP server or something. And we've been able to replace each of those flows with Avalanche. And what you can see on the screen here is Avalanche is saying the first 4 modules there on the left are green because they're done, they're good to go. But the next 4 are not ready. They need to be executed. And this is, again, showing how the UI gives an at-a-glance view of what actually still needs to be done.
Yeah, to add a little bit of more color to the boxes, where when a module reaches its confirmed state, i.e. its internal test has run and succeeded, then it goes into the green state. The yellow state means that the information is available that module needs, but its confirm has failed, meaning that the module now has an opportunity to do the work that it wants to do. And then the gray ones, they cannot be run yet because the information that they provide is not yet available.
Exactly. We wanted to show a little bit more about what the Avalanche UI looks like. One of the biggest features that we sort of, I don't want to say we stumbled into it, but it was a really awesome side benefit, is that everything that Avalanche does is displayed. So not only can the person who's operating the Avalanche console see it, but anyone else can go in and see it as well. Which means when you have something that does end up running a shell script, you can see all the output there. If something goes wrong, you don't have to go hunting around in some other console to figure out what went wrong. It's right there, right on your screen, viewable for everyone. You can watch the status live. You can watch a Terraform plan being applied. You can watch a shell script with all of its output right there on your screen. And it's just been, the engineers we have using this, they're like, where was this tool my whole life? And yeah, so.
Yeah, I think also with the it's not just that it shows you what's happening and you can kind of see what just happened. It also records it in an audit log, everything. So even if maybe a particular set of operations actually succeeded, well, they appeared to succeed, but maybe it didn't do the right thing. So you can go back to that module later on and see this shell script that ran when the platform was first built. What did it actually output? I want to go back and have a look at that. And you can go into the execution history and have a look. What did it actually do?
And in fact, here's what that looks like. Every module that runs is logged, and you can click on any one of them all the way back to however long you want and look at everything that it did. And I mean, if you think about this, if you've ever run an Ansible playbook or a shell script or something, most of the time that's just run off of a terminal session or something, and that log is just gone. Nobody keeps that stuff. And so here you have it. It's there forever. It's for auditing, for just making sure it did what it was supposed to do. It kind of makes sense to keep that stuff.
Another thing I'll mention at this point is if any of your output accidentally, like maybe you called a shell script and you passed a secret to it. I mean, I wouldn't recommend you do that, but it is possible to do. And then your shell script logged it in a debug message accidentally. Avalanche will automatically redact it from all of the logging information.
You shouldn't be doing it anyway, but Avalanche has got your back.
Yeah, in case you make a mistake. We all make mistakes, right?
Sure. If you do need to run shell scripts, and we do often need to run things that only, hold on, this is a different slide. Anyway, I think this was supposed to be a different picture, but, or maybe that's a later one. Anyway, Avalanche does support running shell scripts. And as we've just been saying, when you do run them, you get to see the output right there on the Avalanche console. It's logged, it's kept in the history, and it just makes it a lot easier to deal with running shell scripts. I think there's another slide that I'm thinking of. Okay, let's talk about another major feature of Avalanche, parallelism. Maybe you have to stand up not just one web server, but 10 of them, 20 of them, 30 of them. There's certain tools like Ansible that can be set to run against a set of targets, but oftentimes you spend more time dealing with making inventory files than actually getting the work done. Avalanche automatically supports running against multiple targets. You literally just have to tell it the list of targets, which can come from, for example, a Terraform output, and then it runs everything, whatever operations you need, against all of those targets at the same time. And you can then watch the progress of each target in real time as it's happening.
Yeah, you can also set in the parallel operators how much concurrency you want. So let's say you have a pool of 100 servers, but maybe you're running on Azure, and if you hammer their API too hard, it starts to give you errors. So you're like, okay, I got 100. I don't want to do them one at a time. It's going to take forever, but I know I can do 10 at a time, and I won't get API rate limited. So then you can tell Avalanche run a certain number concurrently. I only want to run 10 concurrently.
Yeah, and it'll handle that.
And in the screenshot of what Alex is showing here, each of those green bars shows that this particular execution ran in parallel, and it was against 3 targets. And so then you can expand each of those 3 targets to see how did each of these machines react.
Yeah, this is like a sort of like a clickable accordion thing that opens up. Templating. So another major powerful feature we have in Avalanche is that you can use template language syntax throughout, literally anywhere, in any shell script, in any Terraform file, in just anywhere you use data. And what this allows is, if you've ever been using Terraform and you've been saying, man, I really wish Terraform just let me just put an if statement around this whole block of Terraform code. Well, now you can do it using Avalanche, because let me tell you, I don't know how well you know Terraform, but if you've ever tried to do it with just count operators, it is just a nightmare. So being able to just disable a whole block of code, in this example here, we're changing the values of a environment variable based on whether we're on Azure or not. And yeah, you could do the same thing using complicated bash conditional code, but sometimes the templating language just makes your life a lot easier. We're using the standard Go template language. So if you're familiar with Go templates, it's very similar, but not exactly the same as Jinja. And it's very powerful. You can do blocks, you can do like internal functions, you can operate on data with lists and arrays, and we support all of that in Avalanche. It's been, especially for our Terraform, it has been a huge boon to be able to have just a little bit more control over what the Terraform HCL language does. But even for shell scripts, being able to just like disable or re-enable whole sections of a script without having to use like bash variables or bash conditionals to do that. It's been great.
And you can also use this templating language in most areas of modules as well. So if you have complex actions that maybe you want to coerce the action to do something slightly different, you can use this logic around it as well.
SQL statements to generate entire SQL queries based on some external template. It's been absolutely wonderful to use this thing. It's really, so in terms of actually writing actions for Avalanche's code base itself, we've mentioned earlier, Avalanche is written in Golang. We've tried to really simplify what an action is in Avalanche, and this is one of the simplest actions we have here. It just logs things to the screen. But what we've tried to do is hide away all of the stuff that Avalanche does behind the scenes to make Avalanche actually work. So your action code, if you decide that you need a new action, for example, let's say you want to write an action that can connect to some other type of service that we don't currently support, we've tried to abstract it so that the actual code you write is all you really have to worry about. all of the behind the scenes of when your action gets run and how a user adds parameters to your action, we have abstracted that all away into just a few functions. So you just define how do you actually call your action and what are some of the parameters it needs in code, and then you just write your action logic here. And we've also built a test framework that allows you to write unit tests that make sure your action is actually working as intended, with mocking and fake web servers and fake SQL servers and so on that allow you to write really, really extensive and comprehensive unit tests to get that code coverage up.
Yeah, it turns out when we built the unit test framework, we were able to do things like, I was recently writing one that its job was to go get a X509 certificate, and in order to do that, it needed to first generate a private key and then generate a CSR from that and then ask for the certificate. So we had already written actions to do those other things. So in the test code for getting a certificate, I could just call other existing Avalanche actions to go do that stuff for me. And so I effectively use the framework to test itself. And so I get even broader coverage from testing other actions as part of sort of getting a certificate. So our overall goal is to grow this library of actions that you need to over time. So I think we're sitting
at over 110 right now.
Yeah, so we've got, and we're building the actions as fast as we need them, and like Alex says, it's designed to be extensible. So this will be an ongoing, never-ending thing. There will always be some new thing we want to talk to, some new service we want to interact with. So.
Yeah, it's definitely one of those things. We've written the actions we need within Snowflake, but the goal is to eventually, well, actually that takes us to our next slide, which says goals. And yeah, we want to bring Avalanche to you, and we do have a goal of open sourcing this tool and making it freely available. We don't have a timeline on that just yet, but that is part of what we were just talking about with the actions. We want to have it so that the community can develop the actions that they need. And those can then be peer-reviewed and be part of the main Avalanche code base for everyone to enjoy.
Yeah, and what we're thinking is to come up with some type of plugin system. So we understand that organizations will probably have some amount of actions that is just really peculiar to their environment that maybe they don't want to push into an open source fork, or either because maybe it's proprietary or confidential. So there's probably like one or two actions that are really specific to us as Snowflake that we wouldn't publish in the public repository. But we want some kind of way that you could actually have your own action library and link it in with the project.
Well, that's the end of our slides. We were thinking we would use this time now to maybe demonstrate a real live version of Avalanche actually running for real.
Yeah, you're brave.
So while I set that up, maybe Terry can talk about the pros and cons of doing live demos.
Yeah, it's funny. I always have this sort of impression of whenever you try a live demo a real live demo in a forum like this, I always like to say that the probability that something will go horribly wrong is directly proportional to the number of people watching it. And then I had this thought today that it's like, well, because it's recorded, does that also include all the people that might potentially watch it in the future? Because, anything that happens now is recorded. So then I kind of wanted to amend it to say the probability of failure is the entire audience that might ever see this. So good luck, Alex.
Now let's see how it goes. So what we have here is a view of the Avalanche Console. This is sort of the main page where you see all of your modules. Avalanche automatically arranges them into a tree. I have a very simple set of modules loaded in right now. There's actually only 2 of them, and they're both already green because this is a very simple example, so it doesn't really do a whole lot. Never mind these error messages here. This is just because I'm not actually connected to anything external right now. But what would be a good thing to try, Terry? Should we try adding a new?
Well, I don't. Is it easy for you to show the actual YAML behind these modules?
Yeah, I think I can switch windows here. Let's see. So I have to stop screen sharing and then start screen sharing again. So let's see if this works. Pause apologies for. Okay, there we go. I think Ula might have to authorize that screen share. There we go. Okay, so what we're looking at here is just a standard text IDE Golang, and these are the modules in our demo here. So we really only have 2 modules right now. We have this module called servers, and it has some common stuff in it as a demo. But basically, this module really only exists to gather some information from the user. In this case, it's using a UI component to do that. And why don't we add a new section here? So we're going to say that we want to ask, I don't know, how about we ask for the username? So I'm just going to uncomment this this code that was already here. And
yeah, I was going to suggest maybe a parameter for the command, and then you could put like the command is ls and the parameter is -l or something like that.
Yeah, let's do that. So I'm actually going to change this. I'm going to say parameter, and then we're going to change this to server.parameter. All right.
Guys,
and
I'm sorry. I'm really sorry for interrupting, but please you enlarge your font.
Yeah, I can do that. I can actually just make the windows a little bit smaller.
No problem at all.
How's that?
Thanks.
Is that better?
Maybe a little bigger.
Okay. How's that?
Okay, I hate myself.
No worries.
No problem.
So if you remember earlier in our presentation, we talked about how everything Avalanche does, every module has to be required or provided. So here we are asking the user to input some data. We also want to say that this is data we are providing. So we're going to provide server.parameter. And these names are completely arbitrary. You get to decide exactly what these names are going to be. And in fact, since I've added a new input here, we actually have to go and add it to our data schema here. And the data schema basically just exists to make sure that the data that you use in your module is sort of predefined. It helps guard against spelling errors. It helps guard against maybe like people putting stuff where it shouldn't belong.
It also means in like sort of a GitOps flow, you could have a different team that's reviewing updates to the schema, so you don't end up with this same information scattered all over the place when somebody is saying, hey, I want to add parameter to underneath server. Maybe the people reviewing the schema say, actually, we already have that information, or here's a better place for you to store that information.
Yeah, we want you to put it over here instead or something. So what I've done here is I've added parameter to the server point in the schema. So that means that my command servers thing can now provide it. If I had not done that, it would have given me an error. And now let's actually put it to use in the next module, the one that will actually use it. So I have to now require it. So I'm going to just duplicate this and write server.parameter as one of the other required pieces of information. And this module is really simple. It just requires these 2 pieces of information, and then it runs this shell script as part of its confirm step. And if we go and take a look at this shell script, it's pretty simple. It literally just uses the templating engine to insert the command that we have provided. So since we've now added the parameter, I'm going to add server.parameter as another input to this shell script. And that's it really. I'm now going to switch back to my other screen. So apologies once again, Ulla, for the switching. Next time I'll just share my whole screen.
No problem. While you do that, I'll answer one of the questions that came in on the comments. Somebody asked, why not just use Terraform user data and then an agent running on the machine like Puppet, Salt, Chef, those kinds of things. This system doesn't preclude that. And so you could have the VMs that you're starting up actually run that. One of the things that you don't get when you have an agent running on the machine is that after you launch the machine, and let's say you finally tuned that, and the machine comes up, and your agent correctly registers back with your Puppet master, or your Salt key enrollment actually worked, and all of that came online. You kind of have to have this out-of-band system. Salt has sort of a message bus that you could use to alert it. But if you've got, so let's say, for example, you were using Salt to bring up all of your infrastructure, and then after that, maybe you needed to, you could do most of it as part of your Salt or Puppet configuration. But let's say, for example, Salt was bringing up a bunch of Nginx web servers. and then you needed to, like, in our case, like Snowflake, for example, and we're bringing up a database engine. So after the database comes online, we want to run some database commands on the system as a whole. They're not run from any one server. So we kind of need to have something outside of an individual server saying, I need to know when the whole service is online, and now I need to make some API calls to it, execute some SQL statements. And so we needed something that was not in things like Salt and Puppet. They kind of take this view of per server. They don't think about the whole system. Whereas Avalanche, depending on in the mode we deploy it, where we sort of treat a deployment as a unit, which consists of dozens of different servers, but the service as a whole, we can now treat that as an entity, and then do things like call the API on the front end, which goes through a load balancer and then hits one of the Nginx machines and then gets routed to one of the backend servers for servicing the request. Now we can have external framework that drives that, but only tries to drive it once we know the other operations are completed, that the machines have actually stood up and run. So, like I said, you could still use Puppet or Salt on the machines themselves and have a confirm step inside Avalanche to see maybe Salt is bringing online your Nginx servers, for example. And so you could have your test be, all I do is I say to Terraform, start the VM, and then my confirm step is wait until I can make a request to port 80 or port 443. And in the back end, what's actually happening is Salt or Puppet is bringing the service online. Hopefully that answers that question.
Yeah, so what I've done here, if you remember from the code side, is I added a new entry into this, and Avalanche doesn't want to like overload your system, so it only does checks about every once a minute or so. So it took it a minute to realize there had been a change, but you can configure that. What it's telling me here, if I click on this module, you'll notice that it's kind of this orange color. It's saying the following data was not provided, server.parameter. And the reason it's not provided is because I haven't actually typed it in yet. So we're going to go into the data entry screen here and select that module. And we can see here that we have those two inputs. I'm actually going to just change this one to LS and this one to LTR, unless you have another suggestion, Terry.
That looks good.
Yeah. Okay. And we're going to submit this, and you're going to see that that went green right away, because now if we go back to the module screen, the information is provided, and so it says module confirmed. And the next one, since our module is very simple, it doesn't really do anything. It just runs a shell script, but it's also confirmed, and we can see that indeed it ran the shell script here with this parameter, and there is the ls command as we expected. So yeah, that's pretty much a very simple example of showing how data can flow from one to another. A few other things, maybe let's look at the data history. So we can actually see that when I changed the command, we can actually look at a diff of what was actually changed here. In fact, we can multi-select. We can see that the command was changed from LS-LTR to LS, and the parameter was added. So that's kind of useful. I'm just running this locally. Otherwise, this would actually have my name here of who it was that actually did this change.
Yeah, the sort of the showing of data diffs and tracking it in here, it was one of the things we grappled with as we sort of moved from where you might have these types of parameters come from some configuration file that's in Git, for example. And it was one of the things that was slowing down our velocity of running these, is that anytime we wanted to change a parameter, then we needed to edit a file, make a commit, do a pull request, wait for that to be merged, and then whatever software was consuming that would then get it. So then we opted to move a bunch of that data into this data store that's in Avalanche. Well, some of the things you lose when you do that is like, well, then how do I see what the history was of things? Because one of the things you get from having it in Git is that you get a history. So we wanted to make sure that there was tracking of all the data changed inside of Avalanche. And while it doesn't have it today, we do intend to add sort of controls into who can change the data. So once we have a more sort of fleshed out role-based access control system for Avalanche, then we could say, for example, only certain users are allowed to make certain changes, or maybe they need to be approved before they're changed. We do have some approval system in here already. I don't know if we can talk about that, Alex.
I don't really have a way to demonstrate it, but we realized that there were going to be some operations that Avalanche might do that you would possibly never want to trust with complete hands-off automation. We have some plans around maybe allowing it to have some kind of trust, but for now, for example, a Terraform plan is one of those things where a Terraform plan might contain something as simple as adding a new security group, or it might also just destroy all of your infrastructure and leave your company in ruins. And so at a minimum, we think it's probably a good idea if a Terraform plan gets reviewed by a person before that is actually allowed to be applied. Now, of course, Terraform itself, if you're already using Terraform Enterprise or Terraform Cloud, they already have a mechanism by which a plan can be viewed on the web. But we wanted to bring that functionality as a native functionality in Avalanche and expand it to not just Terraform, but any kind of we call it an approval. Basically, when there is some operation that needs a person to look over it and say yes or no. And
yeah, the thing you were mentioning about Terraform Enterprise, when you leave a plan in the unapplied state in Terraform Enterprise, it blocks all other changes to that workspace. So you either have to abandon the plan or actually allow it to apply. Whereas the way Avalanche supports Terraform Enterprise, when Avalanche talks to Terraform Enterprise, it'll do the plan, and if it doesn't have an approval, it will tell Terraform Enterprise to abandon the plan. What it will then do is show the user, here's the plan that Terraform wants to do, and I don't have an approval for this particular plan. Do you approve it? And then a user can say yes or no. Then what Avalanche does is talk to Terraform Enterprise again, send the same chunk of configuration, do the plan again, and of course then Terraform generates a new plan. And then what Avalanche does is, again, look for, have I seen this exact plan before? And does it have an approval? Only if it's exactly the same plan and I have an approval for it, it'll then do an apply.
And our goal is...
So this stops you. I mean, you'll see this sometimes where, like Alex said, oh, I just changed I added a rule to a security group, and what Terraform wants to do is delete and recreate the security group. I'm like, well, that will actually cause an outage if that happens. So you'll have an opportunity to see that in the plan because it says delete, and you'll be like, no, I need to come up with a different way to do this.
Yeah, and we have some ideas around how to make it so that, I mean, when we have infrastructure across potentially several hundred Terraform workspaces, how do we apply what is essentially the same plan to every workspace, but it's not exactly the same plan because maybe the IPs are slightly different or the security group IDs are slightly different. So we have some ideas in mind on like how we would say, okay, allow this plan on every workspace, but only if it's very similar to this previously approved plan.
Anyway, I think we got 45 minutes, right? So I think we're actually slightly over our time.
No, I think we have an hour with some time at the end for Q&A.
Okay.
So
that's probably a good time. Then, unless you got anything else, we can take some questions.
So thank you for watching. But yeah, we'd love to take some questions.
Okay, guys, we've got a question. So I put it on the screen. Only find it from Cuba. You should see it.
Yeah, Terry answered that earlier, actually.
Yes, I know, but maybe someone needed. Okay, so I've got a question.
Sure.
I tell only one thing, please. You have time right now to write some question on chat, and we put it on the screen. And before that happened, I'd like to ask you, well, how long was Avalanche made? Because it sounds like a huge thing.
We started it just about a year ago in the end of 2020, and we've kind of just been iterating on it. It hasn't really been our main, like, we haven't had a huge team of people necessarily working on only that. But yeah, we've basically been working on it for about a year now.
Only a year?
Yeah, and there's really only a core team of like 3 or 4 people that have been working on it.
Alex is a coding machine. We will be in some brainstorming session. I'll be like, wouldn't it be cool if we could? And I haven't sort of even finished saying the sentence, and he's like, here goes working. I'm like, okay.
I must say, like, it's my first really big project using Go and using React for the front end, and it's amazing how modern languages have made it just absolutely easy. I mean, you can really just focus on the actual application code that you're trying to do and not all the plumbing around it. If that front end hadn't been developed in React, if it was developed in just like straight plain JavaScript with normal Ajax hooks or something like you would do it 10 years ago, it would have not been as
I
nice.
don't think we would have done a front end. We would be running curl from our command line, just calling the API directly.
Yeah. So the initial prototype for Avalanche was thrown together in just like 2 weeks, and it already had a front end. It already had a working back end with an API and everything. And it's been amazing to be able to use modern tools to really iterate quickly on this.
I think it speaks for a lot when people sort of try these little projects that they don't realize will turn into a big project. You often, cut some serious corners when you start it. But when we started it, we're like, this could grow into something bigger. Let's try and set the sort of foundation right from the beginning. So because people always say, oh, I'll go back and fix it later. And that never happens. So just do it right the first time.
Yes, that's took always longest, but I'd like to ask another thing, because I'm really curious. What's your favorite feature in the Avalanche?
Me personally, I think just I don't know if there's one specific feature. My favorite thing about it, honestly, has been watching. So we had this one guy on our team whose job it was to make deployments, and he used to have to do it the old way, mostly by hand with various scripts and so on, and playbooks and so on. And he would just tell me how stressful it was for him and how frustrating, and that it just wouldn't work half the time. And being able to say, okay, just literally throw all of that away. Here is the new workflow. You literally just watch these little boxes and click these buttons, and it just does it. And just watching him go from like, I don't know about this, to like, I'm sold. This is the best tool I've ever used in my life. This has reduced my stress. This has made my job easier. And like, I love everything about it. I'm like, wow. I mean, I'm not even trying to sell you anything. And so for me, that has been my favorite part about this whole project, is just watching people go from being skeptical to being like, oh my God, where was this tool my whole life? And that's how I feel about it.
I think my favorite feature is how the flow of information through a complex tree of dependencies works. This is a huge area of friction in our organization before. It's fine when you have a team of maybe 3 or 4 people and they all collaborate together. But when you have like 100 people in cloud engineering all working on building and managing your infrastructure, you can't all get in a room and cooperate on something. So there's a lot of handoffs between teams. And we were effectively able to eliminate all of that, because we could go to each team and say, what do you need for your little piece of building a deployment? What information do you need, and what information do you produce? And you write that as code in a YAML set of modules. And now we don't ever have to say, okay, I built the deployment up to stage 7, and now I hand it off to this other team, and they're going to go do their little thing, and then they're going to hand it back to me because they did their little thing to it. It's fine when you have simple infrastructure and like I said, you have a small team managing it. But once it grows to where you have, I think we identified 27 different operational groups within Snowflake that are involved in building a deployment from the day somebody says, I want a deployment, to the time a customer is using it. So most of the time was spent in these handoffs between different groups. So by being able to really clearly describe what information comes to and goes from modules, we remove all of that.
Mm-hmm. Well, that sounds really agile. And I have to say, and I'd like to ask one more question, because sure. I think that I ask about something what everyone is thinking about, and some people afraid to ask. Will Avalanche be released as open source?
So we have already got internal, all the way up to sort of VP approval to release the project as open source. And it's mostly just about us finding the time to sort of, box it up nicely and publish it online. We can't make any commitments right now. I mean, I would love for it to be like tomorrow or next week. It's probably at least several months away, but I can't make any specific commitments on when we'll make it available. But I'm sure, the fact that we can come to forums like this and present about it and make the community excited about a tool like this will help add additional fuel to, hey, hurry up and release this.